Hi everyone, myself Krishatik and very warm welcome to all. And this is day 7 of Foundation AI series. So in this day we're talking about a little bit around some basic concept we should to know. In this is the this is the mathematical foundation concept, and in this neural network architecture, and lots of around it. But we are talking about somehow a little bit differences in this all these categories like weight, and you can say lots of topic about mathematical topic. So overall agenda for today is the first we are going to discuss about weight and gradient, and weight and gradient. In fact, the weight is very important part in this particular machine learning, neural network, and artificial intelligence. Like any system you are designing, weight is very important, and gradient is also important. And back propagation is just such an important part, and forward pass and backward pass. We should to talk about all this, and at the end this is second agenda, this is third agenda. At real world example, we're talking about real world example, much about taking one such as real world application to experience these kinds of the concept much better. And I will try to connect this all this concept to explain you much better about all this particular concept. Like this is a mathematical concept, but I try to connect in this real world example. So that's all about for today. And okay, and so let's get started. Hey, let's come to agenda number one. And in this agenda, we are talking about like weight. So, in this agenda, we are talking about weight and gradient also. But first part is our weight. So, before understanding the weight, so let's come to understand weight. So, before understanding weight, let me know you. Like I give you three word to understand weight much better. Like input, influence, output. So, how much input, influence, output? So that is a weight. So weight is a scalar quantity, and it is a scaling factor. You can a flexible scaling factor which change according to importance. Now suppose for making, as we take like lots of example, but I think the best example is house prediction. So in house prediction we have three kinds of the parameter. Like the first one temperature, second one is the neighborhood, and third one is the footage, square footage. Okay, so how much input is important in such a making decision? Is it sometime this inputs, like the three inputs, as we know, like three inputs, so we given as a weight. According to weight we adjust a weight. So like suppose we given a specific number like integer, and you can say any kinds of number to each weights according to their importance. Now suppose if the location is very important in such as making predicting house, then you can say the weight a scalar, like weight is very high of this particular location. So according to parameter, according to inputs, the weight is a scaling factor, and this is a flexible scaling factor, and it change due to their one of specific use cases according to it. So that's the basic protocol, you can say. So that's how the particular thing is work. So in the case, weight is a scaling factor, and it is a flexible scaling factor. So it is all about a scaling factor, but it is flexible. In somehow it is too much flexible because it depend upon the use cases, like which factor is using more and which feature, which input is using more. So you can adjust weight according to it. So it is in a kind of the specific number and a specific threshold. So it adjusts according to their a specific parameter, you can say, but it adjusts according to use cases. Okay, so in your definition, input, influence, output. Like input, how much the input is important to influencing output, like I will multiply. So in this full neural network architecture, when you predicting cells, now suppose we can take an example like spam and not spam, then how much input multiplied by weight, this is a weight. Okay, and in this weight we can this the scaling, like you can say this magnitude of weight is increase and decrease due to the importance of the input. Like if this particular, now suppose this is location, this is the temperature, this is neighborhood, and this is one, you can say square footage. Then if the location matter much more in this neural network architecture, like predicting a house, then the weight is very high. So basically as we know, like the input it basically weight is basically classified in three category, like the three border category, as we know. Like the first one is positive weight, and second one is negative weight. So in the case of positive weight, now suppose positive weight refer to that very high magnitude. Now suppose as we know, like if this particular model predicting something a spam and not spam, then now suppose this feature matter more, location is matter more, like predicting spam and not spam. That I think like in the case you can think like something one digit of the Gmail is matter most. So you can take input and you can increase the weight magnitude in such way, like you can increase a too much weight magnitude. Okay, and that the particular thing happened, and so that's the positive input. So when making decision, so this positive weight participating more as compared from negative. So learning rate, as you can say, positive weight is much higher. Okay. Second thing is negative weight. So negative weight is all about decreasing the process of the learning. So it's all about, in this neural network architecture, uh, this particular reduce the learning process of this particular goal. Now suppose if the input is, if we increase the importance of the inputs, like now suppose inputs, then I think like output will decrease. So it's all about, and near to zero sometime some kinds of the features not participating in decision, so we need to keep this particular near to zero, and ignoring such kinds of the features. Like now suppose in making predicting house, some kinds of features, you can say location, and you can say like temperature doesn't matter, and in that predicting house, so you can say we keep this particular value as a weight at zero. So it can adjust by, you can say, I already said you about this particular thing is like weight is just such as a scaling factor, so it adjusts according to the neural network framework. So machine can actually adjust a computer, your computer can already adjust, your system can already adjust this, all this thing. So that's the types of weight, and this near to zero and this full neural architecture work. And let's come to the three basic importance that we're looking for is like weight. So weight can change uh, by three factor, that I think like three factor is too much responsible for changing a weight, change weight. So in fact that's why. So the first one is learning rate, second one is input data self. For example, some input data is very high and the importance is very high, so you can say the weight is actually positive and the weight is very high of that particular data. Loss function, according to loss function, some data, some features is playing participating decision, but the loss is very high, like it's not sometime participating. So that's why the gradient, and you can say architecture can decrease the particular flow of this weight, the value of flow, and it's tend to be zero also. Learning rate is responsible because of the learning rate, sometime model learn, but they are not using this kinds of a decision, so that's why they can you can say that's is not responsible for, and they decrease the rate and increase the rate according to learning rate. So increasing the learning rate, the weight can increase, but some features not at all. So that's all about it. As you know, the neural network architecture is all about like you can say uh, the weight, and in short, in my definition, weight is all about the importance of input in output. Like we need to adjust, how can we teach a machine to just think like human, this particular input is important in such making decision or not. So this is the entire magic process, and you can think like this is a full architecture design in such a way, is all about like such a magic concept, you can say. And those who actually think like it is all about inspired by the human brain, and such a very important concept. And weight is important, okay, so weight is just a part which actually play an important role, like influencing input as output. So that's okay. So let's come to understand the gradient. Hey, let's come to understand about gradient. So what exactly gradient is, and so if we understand this gradient, the way to understand the gradient is all about shifting the direction for loss changes. Like now suppose our model is try to learn, okay, and if the model try to learn that they predict something, okay, they predict of something like, and they have lots of problem. Like now suppose model want to learn but they predict something, but if they have some kinds of the differences in actual output and the predicted output, so this is the loss, okay. So their actual output and predicted output, the difference between them is loss. So that's loss, we need to fix this kinds of the loss. So for fixing for fix this kinds of the loss, we need to uh, use some kinds of the method is called backpropagation. And in this backpropagation, one specific term is used, basically used is your gradient. So what exactly gradient is? So gradient is all about giving a direction for loss changes, like reducing a loss. If you if the model want to reduce loss, okay, so gradients give a direction to loss. So it's all about scaling and vector. So it is scalar and vector quantity both. So it's all about vector quantity. Okay, with have a magnitude and direction also. So in this parabola, now suppose this is a loss function and the model want to learn something. Okay, so initially this loss function is reduced, and sometime it this loss function want to reduce from this side. If you look this side, so the slope of this particular gradient, so that how much the rate, like where is the direction for the changing loss function. So if this particular function is moving this direction, then I think like this reducing the loss. Okay, so reducing loss, and the model learns one to again. Okay, so the slope of gradient actually decide the how much your model, your particular network architecture is capable for learning all this stuff. Okay, so it's all about learning process, like giving a direction to shift the weight. Okay, so now suppose your weight, now suppose this particular input, so you can say understand in such way, like now your input want to change, but your where to decide, like where to shift the weight. So is it we need to increase the weight, or is we need to reduce the weight, or is we need to keep a value near to zero or ignore the weight. So who decide, and who given a vector and a scalar quantity, so about the increasing and magnitude. So I think like gradient is responsible for that, to giving us such as uh, you can say giving such a direction and magnitude of their particular thing. So I think that's in my opinion, like gradient is all about giving a direction for a scalar and vector shift of their uh, your you can say it's all about giving a vector shift and scalar shift of their particular loss function, your weight. So your weight is basically it give a direction to increase or decrease your weight, and this is the based on the okay. So it's all about vector and scalar quantity, and you can say this is a factor of the scalar and vector. So okay, in fact that's in working way. So the key variation is all about the basically gradient is classified in a three border category. Like the first one is the batch gradient, SGD gradient, and mini batch gradient. So in this batch gradient we look lots of things, like uh, this gradient change by looking entire data set. Instead of looking one data set, they look toward the entire data set and take a decision where to shift a particular you can say weight. Okay, and this is called a batch gradient. Okay, in fact second one is the SGD gradient, and SGD gradient it take a training example, like looking toward the for lots of example, and they take a training example and find out their where to look. Okay, where to change a shape. For example, they predicted lots of prices of the house prediction, we can say. In this house prediction they take a lots of example, but uh, one of them, they pick one of them and decide where to shift. Okay, so random example they take and shift the weight according to the make decision. So other one is mini batch gradient, or you can say MBG, and MBG is referred to that mini batch gradient. And in this mini batch gradient we are this particular gradient actually decide by entire data set divided into such as mini batch. Like now suppose if you want a 4 data set, so now suppose entire data set, now suppose we can take full data sets. Okay, and we divide this all data sets in border category, and after this we can decide choosing one of them, randomly choose one of them, and fixing this all the issue, like deciding how to increase the weight or not. So that's all about it. So I think like the most fastest process is like this both are fastest process, but I think like batch gradient is fastest process, but they are slow, but both are slow. So you need to choose your own gradient method. So that's all about it. And gradient is all about, in fact gradient is all about vector and scalar unit. So it is a factor of the vector and scalar factor. So it is all about giving direction to where to change, where to shift a weight. Okay, so it's all about it. And it's create a confusion because of that back proposition sounds similar. So I will try to explain you such a difference between both of them. And if this okay, so let's come to agenda number 2 about back propagation. Hey, let's come to agenda number 2, and in this agenda number 2 we're going to discuss about like back propagation, and what is actually back propagation, and where is the use cases also. So should we discuss back propagation? So when we're going to discuss this back propagation, so I will give you such a magic word and a three magic words so that I'll actually help you to understand much better. So backpropagation work like predict, compare, and adjust. The full algorithm is designed. This is a method or this is algorithm. It's designed to just predict something. The predict. Okay, now suppose your model predicting something. They calculate, compare, and calculate the loss. Like they calculate loss. Loss in like actual output and predicted output, like looking between difference between actual output and predicted output. And then after they move toward the adjust, so it's all about adjust. They adjust all these parameters, so they adjust weight. Okay, what they calculate gradient. The calculation happen here is gradient. They move layer by layer, so it's a method or algorithm to moving layer by layer to calculate gradient and fix and adjust the weight. Sorry, I miss here. So to adjust a weight, so for adjusting a weight, so it's look like a method or algorithm. It is a method or algorithm to specially design to calculate moving layer by layer, like moving layer by layer to calculate gradient and fix and adjust weight. Okay, so it's all about adjust weight. In fact, that's the important point we should to note down. But in this lots of area, we can calculate or adjust weight in lots of things. Like the first one is forward pass. You need to understand this forward pass. So forward pass is all about input, hidden layer, and output. So it take a input, okay, and second one is the hidden layer, third one is output. So take input and move to the second layer by activation percentage. You know, input and weight multiply plus bias is added. Okay, bias added, and then move toward then main computation happen here and they predict output. Okay, after this process, one more thing happen. One more thing happen is like backward pass. So backward pass is just reverse of this process. Okay, now they predicted something and the something they predict and they look toward their actual output and their predicted output, like looking difference between all of them. Okay, so what the difference between all of them, they predict. Okay, then after they move backward, so they reverse the all entire process and okay, that's fine. They reverse entire process and move toward their uh, computing part, like calculate gradient. So it is an algorithm which is especially designed for calculating gradient by backward pass. So it's move reverse process to just calculating gradient and know what is the fault and they adjust the weight according to it. So it's all about, you can say, they predict and they look the difference between actual output and predicted out and calculate loss, and then after they shift the gradient in each layer by backward pass. Okay, and they adjust it the weight according to it. So that's my thing, that's all about it. So that's all about backpropagation. And backpropagation in simple term, you can understand the backpropagation in like predict, compare, and output. So this is the entire algorithm and method which is actually designed to such as solving this kinds of the problem, like calculating gradient. So gradient is all about unit, so scalar and vector unit, which is basically is in a magnitude or vector, like giving a direction or magnitude both. So it is itself and quantity, so which shows that how much does something need to change and some all this stuff. So that's all about it. And this is the entire process of backpropagation. And okay, so let's come to agenda number 3 for real world example and for experience much more about this real world application from this real world application. At the end, I always try to just take a real world application to understand much better about this all these concepts that we learn. So hey, let's come to agenda number 3. And in this agenda 3, we are talking about like real world application. So what kind of the real world application that is, basically I will connect this all the real world application to all this concept to explaining you much better to experience this kinds of the concept. So let's come so on my learning journey, like basically this is one of the best example, and this is a magical example, you can say. Because of that, why I'm saying this is a best example. uh, Now this is the, you can say, this is one of changing you can say life of the human, and this is this particular example show you like how actually uh, artificial intelligence create a such as environment to the such as you can say can think like something you can say artificial intelligence is a evolution like is a participating evolution of the human like living being. So it's example. So and one of my best example, and I inspired from this example too much because of that, that is best example from Google DeepMind. So Google DeepMind basically uh, is responsible for this particular example. I'm not going to sponsor this kinds of the example. In fact, the Google DeepMind actually Mac such as AlphaFold. So AlphaFold is a basically model which is actually designed for predicting protein structure. So I think like for predicting protein structure, you should to know about because of that. This is very important, and this is a biological concept you should know because uh, predicting protein structure for the scientists like huge scientist team like 50 people, 50 researchers, machines come together and take a 15 year to predict one molecule structure of the protein, one molecule sequence of amino acid. So it's all about like predicting amino acid structure, like valuable structure. So changing a protein structure have an all different structure to right structure to choose uh, of the protein. Okay, and it take a 50 years. And the story behind it like Google DeepMind solved this particular problem by CASP 15, I think like 15 16. Okay, CASP 15 16. So it solved this particular example, and because of that the Google DeepMind is too much accurate and passionate about this particular problem, and Demis Hassabis is the hero behind the scene. And I'm really too much excited about Demis Hassabis, and you can just a huge fan of Demis Hassabis. So that's all about it. And they predict a protein structure in such a way like now suppose a gradient weight. So AlphaFold is all about like this is the amino acid sequence. We need to predict right protein structure to solve the problem. Like for example, when you discover a protein, when researcher want to discover, so it take a 50 year to predict one single molecular structure of the protein. Now Google DeepMind solved this particular problem, especially the my hero Demis Hassabis solved this particular problem in such way like they predict protein structure in I think like 100 to like 150 100 somehow they predict the protein structure in such as a few seconds after making a AlphaFold. You can't imagine like 15 years problem, like it take a long timeline to solve the particular problem when like 50 years long timeline to researcher to continuous work consistently to one single structure, and Google DeepMind solve this particular problem in such as few seconds. So that's the interesting one. And you can say this is responsible for that 50 years to take a one problem solving. And how actually what the biology behind it, so I will explain you. Now suppose this is a protein of coronavirus, so we need to fold a protein in such way to find the antibiotic to coronavirus. So this is amino acid sequence, and we need to predict arrange this right structure to predict a protein structure. So it's all about it. And that's AlphaFold is responsible for. And this is a great work of Demis Hassabis, and so that's why I am too much excited about this discovery. And this discovery is one of the best scientific research all over in the party in this world, showing the power of artificial intelligence, how artificial intelligence just changed the all over the world after in coming in the full potential. So come in the full potential. So that. So let's come to their input, and this one the hidden layer and output. So let me understand this how actually our concept works behind this particular architecture. So basically it's all about Google DeepMind discuss it, and I want to explain you like this one is input layer, hidden layer, and output layer. So now suppose they give us some kinds of the protein structure, and this protein structure amino acid sequence. This amino acid sequence is converted in input layer as a node and different kinds of neurons. And after this neuron, this hidden layer, and second one is the output layer, is the predict right protein. Okay, they do mixed tech. Okay, so where is the weight? what is where is the weight used here? So weight is used here like amino acid sequence. We need to look like right structure. Like now suppose this is amino acids, we need to decode DNA. Now suppose DNA is here, okay, in the protein we have now suppose DNA. So each DNA part, we can take each DNA part as input and we multiply it with weight. So weight is work here as a in the sequence as a, you can say they look toward the all input part. Okay, so in right way, so looking toward look toward their uh, each input parts as your inputs, like how much inputs parts participating in right structure. So that's the workflow of the weight. Second one is gradient. So gradient, where is the gradient? As you know, gradient is as a scalar and vector quantity only for. Okay, so now suppose model predicts some structure. Now suppose this. Okay, but our structure is like this. Then how much difference between this one predicted architect product, like predicted output, and actual output? Like they look the differences between them and calculate loss. Okay, and okay, so they move the backward pass. The process happen like backward pass. Okay, so backward pass, the first, if the moving particular thing is from this side to left to right, then you can the forward pass, and right to left, then backward pass. So then process the backward pass happen, and they look toward the losses, and they calculate the gradient by back propagation method. So back propagation algorithm is designed to calculate layer by layer all this gradient. Like gradient is all about quantity, like vector and scalar quantity, which is responsible for. So that's how they calculate this all the gradient and reduce the loss. Okay, so that's the particular back propagation work, and so that's how this actually gradient, weight, back propagation work. But in fact, if you're looking toward the more excited example, as AlphaGo is the best example, actually discovered by the Google DeepMind, and Google DeepMind is responsible for lots of scientific discovery. But in future, they are working on quantum computer and lots of example. But I think like that is exciting time for now to just as entrepreneurship and lots of things. But I want to say that like this one is the important part to just looking toward this, and AlphaFold is the best example for protein structure, predicting protein structure, and that's all about. Okay, so if this particular video is going to productive for you, and if you learn something for there, then it's my pleasure. So let's get see you soon.